In this video, we will discuss questions regarding cathode rays and anode rays. First, we will compare the characteristics of cathode and anode rays. Anode rays is also known as positive rays. Cathode rays are negatively charged and positive rays are positively charged. Cathode rays move in straight lines and anode rays also move in straight lines. Cathode rays are mainly generated from the cathode and a small amount is generated from gases. Positive rays are generated only from gases. The thing we refer to as gas is the gas present in the cathode ray tube. When cathode rays or anode rays enter a magnetic field, they do not deflect towards the North Pole or the South Pole. These rays deflect perpendicularly in the magnetic field. Both cathode rays and positive rays have momentum. Momentum is the product of mass and velocity. If a particle has a mass and a velocity, it is said to have momentum. Cathode rays can generate X-rays, but anode rays cannot generate X-rays. Cathode rays can penetrate through thin metal sheets, and anode rays cannot penetrate through thin metal sheets. Now let's move to the next question. What is the structural difference between the tubes used in the formation of cathode rays and positive rays? The tube that generates the cathode rays contains a normal cathode. The tube that generates positive rays contains a perforated cathode. Perforated cathode is the normal cathode with holes. We use the same kind of tube to generate cathode rays and anode rays, and that is called as the cathode ray tube. Next question. Who discovered the lightest positive ray particle and how? Ernest Rutherford discovered the lightest positive ray particle. He used hydrogen gas as the gas inside the tube. This particle was named as proton by Rutherford. When the voltage is increased and pressure is decreased inside the tube, the bond between the two hydrogen atoms of hydrogen molecule break and result in two separate hydrogen atoms. When we further increase the voltage and decrease the pressure, an electron is removed from each hydrogen atom and result in two hydrogen ions. This hydrogen ion formed is considered as the smallest positive ray particle. Now let's demonstrate the following procedure using a diagram. Next question. State whether the following statements are true or false. The first statement, cathode rays deflect in magnetic fields. It is true. Second one, cathode rays contain positively charged particle. It's incorrect. Cathode rays can penetrate through very thin aluminium sheets. That is correct. Fourth one, cathode rays consist of alpha ray particles. Alpha rays are positively charged and cathode rays are negatively charged. Therefore, this statement is incorrect. Fifth one, cathode ray particles are negatively charged, correct. Travel in straight lines, correct. Are attracted towards the north magnetic pole, incorrect. Are attracted towards the south magnetic pole, incorrect. Sixth one, electrons tend to move in a curved path in a magnetic field. It is correct. Let's show this using a diagram. The cross represents moving perpendicularly inside of the magnetic field, and the dot represents moving perpendicularly out of the magnetic field. Sixth one, electrons tend to move in a curved path in a magnetic field. That statement is correct. Seventh one, electrons have both particle and wave property. This statement is correct. Eighth one, electrons cannot be added or removed from an atom. This statement is false. When an electron is added to an atom, an anion is formed, and when an electron is removed from an atom, a cation is formed. Ninth one, the speed of an electron is equal to the speed of light. It is incorrect. The 10th one, and proton is heavier than a neutron. It is incorrect. 11th one, all atoms have electrons, protons and neutrons. Incorrect. For example, hydrogen has 3 isotopes: hydrogen, deuterium and tritium. Out of these 3 isotopes, the one with mass number 1 do not have a neutron. Atomic number is indicated on the bottom and mass number is indicated on the top. 12th one, all ions have at least one proton. It is correct. H plus ion is the smallest ion and it has one proton. 13. Electrons behave sometimes as particles and sometimes as waves. It is incorrect. 14. Cathode rays consist of electrons. It is correct. Both electrons and cathode rays are negatively charged, so we consider cathode rays consist of electrons. 15. Cathode rays are attracted towards the positive end in an electric field. It is correct. Simply, any negatively charged particle is attracted towards a positively charged particle and vice versa. 16. Cathode rays have momentum. Correct. 17. All atoms have protons. Correct. 18. Electrons are not considered waves but particles. Incorrect. Electrons are considered as both waves and particles at the same time. 19. Cathode rays have both mass and charge. It is correct. Mass is 9.107 into 10 to the power minus 31 kilograms. Charge is minus 1.602 into 10 to the power minus 19 coulomb. 20. The speed of the cathode ray is less than that of light. It is correct. 21. Cathode rays travel in straight lines towards the cathode. It is correct. 22. Cathode rays produce fluorescent discharge through the walls of the tube. It is correct. 23. Cathode rays produce heating effect. Correct. 24. Cathode rays can affect photographic plate. Incorrect. Now let's move to the next question. What are the requirements that should be present in the discharge tube for the emission of cathode rays? First requirement is high voltage, which is between 10,000 to 15,000 volts. The next requirement is low pressure, which is 0.01 to 0.001 mercury millimeters. Now let's move to the next question. Explain the following statements. First statement, charge of positive rays can vary according to the gas filled in the tube. This statement is correct. When positive rays move inside the tube, they meet other particles and collide with them. Therefore, they get more and more charged by liberating electrons. Also, number of ionizable electrons is different in atoms. Therefore, differently charged positive rays are formed. Ions like N+, N2+, N3+ formed by removing electrons from nitrogen atom are called positive rays. Second statement, multi-electronic species have more electrons which can be ionized, so they form differently charged ions. This statement is correct. Differently charged ions formed by removing electrons from oxygen atoms are positive rays. Third statement, the properties of cathode ray particles depend on the element. This statement is false. Cathode rays are electrons, therefore they do not differ from element to element. Cathode rays are identical. Fourth statement, positive rays can be generated by liberating electrons from molecules. This statement is true. Positive rays are formed from atoms or molecules. If it is a molecule, it should be an odd electron molecule. Such odd electron molecules are NO2, NO, ClO2. Fifth one, cathode rays are generated at the anode. This statement is false. Cathode rays are mainly generated from cathode and a small amount is generated at the anode. Sixth one, positive rays are generated at the anode. This statement is false. Positive rays are generated only from the gas. Now let's move to the next question. What are the observations in the Crook's tube during the experimental formation of cathode ray particles? First, we will draw the experimental setup of the Crook's tube. Crook's tube is also known as cathode ray tube, which consists of an anode and a cathode which is connected to a power supply. This Crook's tube is connected to a vacuum pump. This involves in reducing the pressure of the experimental setup. The power supply used here is most probably an induction coil. The induction coil is used to increase the voltage of the setup. Now let's discuss the observations during the experiment. A greeny glow appears on the cathode. It moves towards the anode. In between anode and the green glow, a dark patch appears. When the pressure is further reduced, dark patch starts to spread and become more concentrated between the anode and the cathode. We call this instance the Crook's dark area. When the pressure is about 0.01 to 0.001 mercury millimeters, some green glowing particles start to move from cathode to anode, which are known as cathode rays.